All right, dividing radicals. So there's a little bit more to this, and you have a little more freedom to solve these different ways. So first, I just want to start off by saying there's a couple of ways you can think about this. So if I have the square root of a over the square root of b, square root of something over the square root of something else. Another way to write that is the square root of a over b, because sometimes it's easier to simplify this fraction and then take the square root of that. Other times, you may have something that's like this, and it may be easier to make the square root of a over the square root of b like that. Then you can simplify the top and the bottom separately. So those are two ways to think of it. Now, first, one thing you want to do is see if the numerator and denominator are perfect squares. If the numerator and or the denominator, if you find any perfect squares, we'll simplify those right away. All right? Then you want to see if you can divide the bottom into the top, or vice versa. Basically, you want to try and reduce the fraction. So if you can reduce before you even start simplifying, that's the thing to do. Simplify any radicals that are easily simplified, and then you have to rationalize the denominator, which is a new thing, which I actually got a special slide on, and we will talk about that. Basically, it just means you can't have a radical on the bottom. So these are all illegal if you simplify and still have a radical on the bottom. So let's get at it. These two are both perfect squares, right? Square root of 9 is 3, and the square root of 16 is 4. Bam, done. 3 over 4. All right, this is the square root of 25 is 5. The square root of 36 is 6, so we get a 5. This is equivalent to a 5. This is equivalent to a 6. We get a 5 over 6. All right, now neither of these are perfect squares, but let's see this rule over here. Check it out. We can write this as the square root of 27 over 3. Now what's 27 divided by 3? Or 27 over 3 reduces to a 9. So that's the same as a 9 over 1, which is the same as just the square root of 9 over 1 is just 9. Square root of 9 is 3. So those all simplified to whole numbers. So now I'm going to move this over. You know, rewind and rewatch if you have to, but I want some space to do this one. So what can we do here? I got a 5 over 10 on the outside. So what I'm going to do is reduce those right off the bat. So that's going to be like a 1, which I don't actually have to write the 1, but 1 over 2 times a 48 over root 12. So I could simplify the root 48, simplify the root 12 first and see what cancels. But I notice that 12 goes into 48. So I'm going to write that as a 1/2 times square root of 48 over 12. All right, what's 48 divided by 12? Well, that's just 4. So that's 1/2 the square root of 4, because 48 divided by 12 is 4. So then we got 1/2. What's the square root of 4? The square root of 4 is 2. So that's 1/2 times 2. Now 1/2 times 2 is just 1. There's my final answer. So this all simplified to 1. All right, let's now see some more examples. Here, any perfect squares? No, they're not perfect squares. So we're going to use that same method because I notice they're both even numbers, so I can definitely reduce them. I can at least divide a 2 out of both. But then I notice also that 6 goes into 42. So this is the same as square root of 7. Now 7 is not a perfect square. 7 doesn't factor to anything, so this is final answer. So look at, we got 5 over 20. So I can reduce this fraction, right? If I divide, so I still have 2 times. If I divide the top by 5 and divide the bottom by 5, I get a 1 over 4. So that's the same as 2 times. Now this is like a 2 over 1, so the 2 is technically on top, if that's what you would like to. I hate air quotes, but whatever. 2 is on top here. So that'd be square root of 1 over square root of 4. Well, what's the square root of 4? We know square root of 4 is 2, so that's like 2 Square root of 1 is just 1, so I can write the times 1, but I don't need it. And then root 4 is equal to 2. So now these reduce, and I get a 1 over 1, or just 1. That's my final answer. So this all simplifies to 1. All right, let's move some of this out of the way here. And we're going to do this one here. So I can, again, reduce. I got a 6 over 27. They're both divisible by 3. So I'm going to say that this is a 1/5 times root 3 divided into 6. So divide the top by 3, divide the bottom by 3, and that gives me a 2 over 9. 6 divided by 3 is 2, 27 divided by 3 is 9. Only works if you can divide the top and bottom by the same thing. So now I'm going to break it apart. So I got 1/5 times root 2 over root 9. Remember we said that there's two ways to think of those. So this is going from this to that. So root 2 over root 9, root 2 is as simplified as possible. Root 9 is really a 3, right? The square root of 9 is 3. So I have 1 times root 2 over 5 times 3, which gives me 1 times root 2 is just root 2, and 5 times 3 is 15. Done. Here we got, move this over, give me a little more room. So here we got a 65 over 16. I notice right off the bat, that's a 16. So that is a perfect square. So I have 1/2 times root 65. Always rewrite the whole thing, even the parts you don't change, times 4. So I have a 2 times 4 on the bottom. So I'm going to write root 65 over 8. Now I still got to deal with root 65. Let's see if that's reducible or simplifiable. So 65 is a product of 5 and 13, which they don't break into anything else. So there's no two numbers to pull out, so root 65 over 8 is as simplified as possible. Now, we talked about rationalizing the denominator. So far, all of these have just had whole numbers on the bottom or no bottom, really. Well, technically, this is like over 1. But there's been no radical on the bottom. You're not allowed to leave a radical on the bottom. And I think this is more an artifact of how people used to do math when they didn't have computers. But the state of New Hampshire says that you must simplify and get a radical out of the bottom. So we're going to teach you how to do that. Here's the basic technique. All right, this is the one to watch. This is the the quintessential example here. How do I get this to be a whole number? All right, not a radical. Well, I can't just multiply this or change the bottom, but with a fraction I can always multiply the top and the bottom by the same thing. So what would I want to multiply that by that would make this a whole number? Well, how about root 5? What's square root of 5 times square root of 5? That's 5. But I can't just multiply the bottom. I have to multiply the top and bottom by the exact same thing. Because now really I'm just multiplying by something over itself, which is equal to 1. So if I'm multiplying something by 1, I'm not actually changing the value of that number. So I multiply my fraction straight across, and that gives me a root 5 over square root of 5 times square root of 5 is 25. No, sorry. Square root of 5 times square root of 5 is 5. It's an easy mistake to make. Don't make it on a test or something. Root 5 times root 5 is 5. There's your final answer. All right? You are not allowed to simplify these. You cannot do one of these. This is this 1 over 1. You can't do that here, okay? Because this is a square root of 5. It's not the same as just a 5. So you cannot simplify that way. Now, here we've got root 3 on the bottom. So what should we multiply? It's root 7 on the top, but I don't care. I'm going to do a root 3 over root 3. Because root 3 times root 3 gives me a plain old 3 on the bottom. And back to class 1 that we talked about Simplifying radicals, root 7 times root 3 is going to be root 7 times 3. There's no pair of numbers to pull out and simplify, so we just have square root of 21, 7 times 3, over 3. Again, do not try to simplify this any further. It is. You cannot reduce this fraction because it's not really a normal fraction with a radical on top. So now we're going to do our last one here. So right off the bat, I notice that I can reduce these. This 3 and this 6 is just like your plain old 3 over 6, which would reduce to 1 over 2 any old day of the week. So that's going to be 1 root 6 over root 3, 2 root 3. Now, you should notice that 3 goes into 6. So this is what you should do. You should notice that, so you have a 1/2, and you have a 6 over 3, and then that reduces to 1/2 root 2 over 1, which is the same as 1/2 times root 2 over root 1. Root 1, square root of 1 is just 1. Anything times 1 is itself, so I just have this times 1. And that leaves me with root 2 over 2. All right, there are your U-try problems. Here are the directions to refresh you and remind you. And good luck. I'll see you tomorrow.